Our first speaker today is Pedram Hayati. He's a security expert, the founder of SecTalks Meetup and SecDim Software Engineering Academy. And today he will talk to us about a rather unknown edge case that allows an adversary to run root commands inside the rootless container. And he will also tell us how to fix it. And Pedram told us that he might ask some questions to the audience while he talks. So feel free to, like I said, either raise your hand to engage or just use the chat if you're shy. So Pedram, the floor is yours.
Well, thank you very much. Good evening, everyone. It was, I think, rather 3 years ago, I was in this meetup, and I don't know whether any of you remember me in 3D.
Yep, I do.
Oh,
You talked about Flask and just running 2 commands and gaining access to the server.
Okay, all right, good. Yeah, I really hope that this talk would be also in 3D, but who knows, maybe while I am here in Slovenia, we can catch up or go for some drinks and things like that.
Soon. I think we can, yeah, in a month or two. Next time you're in Slovenia.
Perfect.
We'll keep that in mind.
So this talk, okay, I need to go a little bit quick, and also I need to cut down a few parts, and I hope by the end I reach to that promise that I made in the talk description. I need to build a few things before I reach to give you, the whole crown jewels. It can't be just here you go. You need to go through it. You need to see the difficulties in things like that. So first of all, yeah, I will ask questions. You can use chat or you can just shout out. First things first, just clear these things out. Containers are not containers, nor security isolations, nor sandbox. I know the name may be a bit confusing, but container do not gives us any advantage in terms of security. Now, the reason I'm talking about this is because I work with engineers, and I often felt this misunderstanding that because the name is container, we feel that, oh, my program runs in a container, so I should be safe. But actually, we may be even worse off. The other thing, containers obviously is not virtualization. Like a VM that we run, there is no concept of virtual CPU or virtual memory. Containers are effectively a process, a child process, put it that way, that runs by a parent process. And this parent process is called container, and the child process is our program. And it's shared along with other processes that we have on the host. The only thing that parent does is, like many other parents will do to their child, they just limit the word view of the child process. Just say, hey, I don't want to show you everything. I will just show you a limited set of processes, network stack, and things like that. Okay, I'm simplifying a few things here, just to give us an idea that when we work with a container, and like many other processes that we have in a system, that process need to be executed by a user, right? You need a user account need to run any process. And by default, this process in the majority installation of the containers is root, which is not a good thing. Now, I'm going to skip a few slides and head to this slide here. And here I'm going to also ask some questions about that black thing you may see in the screen. The focus of my talk is about those container definitions or schemas, or specifically here, the Docker files that we may build or use or create or push or whatever. Now, can I just get maybe a show of hand, or maybe just number one, if you are involved writing Docker files? Or just put something in the chat. Perhaps I can see how many people here are actually.
Oh, okay. Raised.
How can I see the chat? Oh, yeah. Familiar with this. So how many we got? I can't for some reason see the chat, but
yeah. I raised my hand if that counts.
Yes, that counts. So we got beautiful. So Docker file. Okay, that's great. So one thing I want to mention is, unfortunately, a lot of Docker files that we build, including the official Docker images that we based our Docker file on, is insecure. They're not hardened, and we will see the few of them. And similarly, we receive what we call it insecure patterns when these Docker files are being built. Now, let's look at these 4 lines of Docker file here. Do you see any problem? Obviously, from a security standpoint.
Yeah, that environmental variable.
Is it bad? This one? Yeah. Yes. Is it bad?
Yeah, if you get access to the environment, you can see it, right?
Perfect. That was number 1. What else?
Well, you're importing an image that you don't have control over, maybe.
100%. Like, who is this Bob guy? This custom Docker image. Perfect. What else?
Who knows what's in the JS file?
Hopefully that is my own program. Oh, I hope that's that case. I have control over this one. What else?
Is it running root?
Can someone tell me? Is it so?
Depends on the base.
Depends who deploys it. It runs as a root. And I'm sure about that because of this, right? When we're exposing anything less than port 10, well, 1024, definitely we need root on it. So we already identified 4. There is actually one more. I'll leave this one as a bonus. Maybe by the end of the talk, someone can point me to that. So now what I want to do is, so this means that since there is quite a lot of things can go wrong in terms of when we define these container images, and there are a number of obvious weaknesses when we define Docker files or containers in general. Now, I'm gonna now focus on one of the perhaps widely known but not widely understood problem in a container. And hopefully if I have more time, I will reach to the promise of my talk, that how you can even get root in a rootless container. Okay, first thing first, I need to clear 2 things out here. There's a difference between running a process as root in the container versus running a container as root. Now, if some people have background in Red Hat, most likely they would 100% understood what I mean by now. And this is something that often we play around. Now, let me start by talking about the first one, running a process as root in a container. Now, for a minute, let's just forget about the container word. Let's just go back to the old way of running processes on a host. We all know that when we run something as a root, if any breach or a compromise happen, well, that means that since that process was run as a root, that process will have, the adversary at the moment will have access to everything on the host. That means whatever the root owns. Now, when it comes to the container, the story is pretty much similar. Now, if I run, say, a process like Nginx as a root in a container, and as Roman, you mentioned, that's a default behavior. A breach means that they will get access to whatever root has access inside the container, and to some of the shared host resources. So some of those resources that are shared from the host, this could include some volumes that we map. This could include environment variable. This could include some of the devices that we may share, and it is required by the container and so forth. Let's just perhaps go through one demo here. Now, so before coming here is that, so back in the days, we learned the lesson that actually was related to Apache at the time, that it was just getting pwned all the time. Sorry, pwned means get compromised all the time. And then we're like, can't we just find a different way to run this Apache process? And then the whole idea of the forking, and then fork is run by a nobody user on the majority of the Linux system. Same behavior with Nginx. But for some reason, when we moved to Docker, we forgot about this very nice control that we had. So let's just look at it a little bit. So what I have here, do you see my terminal as well? Okay.
Yeah.
I got a low privilege user on this Linux system. If you're wondering what it is Arch Linux. And just give you the groups that I have access here. So I don't know what is auto login, but I know Docker and Alice. So this user does have access to run some Docker commands. Now I can just, spin up a simple, this is just for demo purposes. So a BusyBox image, and I just get a shell from this. So I'm running the official BusyBox image here. Now, most likely, you're familiar with Linux, you already know that I'm actually root now. If you press ID, you can see, yeah, my UID is 0. And that tells me that I'm now root inside the container. And this was obviously the official image. So, and suppose that, we are in a stage that the attacker is, or the adversary is able to have access to the container. I can hear myself now. There's an echo here. Okay, it's gone. And now attacker is able to access whatever root has access to. So just as, again, demo purposes, shadow file is the file that normally only root has access. The other thing perhaps is interesting for us to know, this is to just kind of demystify some of the facts about Docker, is this UID map. It's quite an interesting one. The UID map tells me that my UI, the UID 0, that is a UI, sorry, that is the ID that I'm running on, is mapped to UID 0 on the host. So this means that, and forget about this number for now, that means that the root in a container is a root on the host. The only thing here, you may be wondering that, obviously, because I'm in a container, I have a limited worldview. That parent process just limit my worldview. I'm not able to see things. But if there is a slight way for me to see other things, I'm effectively root for those host resources. And if you're curious what these numbers are, these are effectively the number of not mapped UIDs. So we may have multiple processes running, and they will eventually get mapped from this pool of UID maps that I have. The other thing, just to prove the fact that I'm actually on the host, and whatever I'm doing here inside the container. And by the way, guys, if you are doing Kubernetes or whatever cloud, this is exact same story. And now it's just on my box. I'm using the default container D here, but the story is exactly the same. They are not doing anything extra. So what I just done, I just keep running ls command in a loop, because I'm now gonna create a new panel. If I can contribute create, and here I'm on the host. As a different user, doesn't really matter, but I just want to get a PS of the resources here. Now see something interesting here. Now right at the bottom, this is my ls command that I'm running. And if you go all the way here, that is the guy root. So that is just to show, yep, that process is actually running as a root on the host. And as I said, container doesn't do anything. It's just a fancy, well, it just limits the worldview of these processes, which are effectively child processes for the parent. This is, most likely you heard about, this is just when you see it, you may feel a little bit different from running those or leaving those Docker containers wild and let them unleashed in the in your environment, because that is really what is happening. They are just there running as root. Okay. Now let me move back to the presentation to just talk about the other part that. Now, so we talked about running a process as a root in a container. That's the default behavior. Now, running a container as a root, that means that the container daemon or Docker daemon itself also runs as a root. And again, that's a default behavior. Why it happens? Because historically, that the Docker needs to provide some resources to the container that is spinning off. Or I think the word is spinning off, it doesn't really make sense. It's just for those forked processes, those child processes that it will create. So for example, it wants to limit the passes that are accessible to that container. For that, it needed root. Now another, so that historically required as a root, and there was a lot of discussion, hey, can we somehow get rid of this behavior? Because, and this, I'm going back to the conversation at the beginning that, in Apache and Nginx, we learned a lesson. We said, okay, once we initialize everything, we're gonna demote it or demote that to a low privilege user. But in Docker, that never happened. It just, once it runs, it's always run as a root. Now, one thing perhaps would be interesting for you to know is this: Docker effectively is a client and server service, and it actually has a HTTP endpoint. So effectively, the Docker CLI that we are running, it just creates a HTTP call to this server that is normally exposed on a specific port, and by default on Linux is on a socket. But we are talking about HTTP here. So is that bad? It can be very bad. Why? It's because if this Docker service or daemon is exposed to the container, and do you guys know which situation normally this Docker daemon is exposed to the container itself? Can you just give me one very, very common scenario that normally this Docker thing is exposed to the container? You can think about one scenario. I'm sure you're using it. 100%. Okay, so Docker in Docker, CI/CD. The containers that are that was being built and deployed, they're effectively inside another container. And for that to happen, that parent container need to have access to the host, the Docker daemon or the Docker daemons that it runs. So that means that effectively you can do whatever someone on the host can do to the containers. This is, again, just want to make it very simple that effectively we are dealing with a HTTP REST API here. And if some of you have heard about the attack that is known as server-side request forgery, I know in a security world we are very horrible to pick names. It's just, I don't know, couldn't we find a simpler name for the attacks? But server-side request forgery is effectively means that attacker managed to is a program that this program allows an attacker to proxy his request to some other internal hosts, right? So I can use this program. It's like, think about like a proxy that I can use it, and then I can say send a request to an internal, I don't know, router, to internal CI or the Jenkins server, or in this case, because the Docker daemon is HTTP, attacker now can directly send the request to Docker daemon, and they would be able to create a container, delete the container, and do all the crazy things. Now, this scenario I just described is kind of not so widely known when people are talking about SSRF. They're talking about other one, but that's also happened in a container. Anyway, so what's the problem here is that when our container runs, they will have full access on the host. So meaning that if that daemon get breached, everything on the host will also get breached. So kind of back in 1980s, that once Apache is compromised, we kind of everything on the host is compromised, and that's now the situation with Docker. Now another demo. This could be perhaps interesting, more interesting than the previous one. So I showed you before that this user that I'm running, Alice, it's only have access to the Docker and Alice, and it can't do anything. It is a low privileged user. If I can't go, like, for example, open up the shadow file and things like that. Now, I'm going to show you that by just giving someone, and by someone, I just don't mean a user. It could, by giving a process access to Docker group, you have given that process and user a root access on the host. So check this out. So I'm just running the same thing. So Docker run dash IP shadow. Now, so that was the shadow file that I didn't have access to. I just mounted to one of my things here, something inside the container, and following with busybox sh. So, what I did here wrong, shadow. Oh yeah, of course, this extra busybox. There we go. All right. Again, I'm rooting the host inside. I'm not inside the container. I'm root. I can not only read the shadow file inside the container, but I can access that shared host resource as well. So this was just one simple example that outside the container, I'm low privileged. Inside the container, I can do whatever I want. I'm effectively root also on the host. Now, again, don't get confused by this example that I actually run a Docker command. This is just for a demo purpose. Think about your program that runs inside the container. If this program has access to this Docker group, that's it. That means that program can become a root outside the container. So hopefully that highlighted the problem that we are having here with this. Okay, so how many more minutes I have to go?
Let's do say 5. Let's do 5.
Let's just then wrap it up.
Well, this is very interesting. So please do go on.
Yeah, been more.
Okay. So, okay, so I wanted to actually show you an actual example of this. All right, so I'm going to run a lab, and this lab is coming from one of the free resources we have. But if anyone wants to follow on, it's the learn.secteam.com, and then you head to Docker and go through this one. This is an interesting one because I'm going to actually show you in reality, apart from, I'm just running some commands. Some of you may say, hey, you just, you prepared all the environment for yourself to demo. I would just want to show you an actual incident that happens with exactly exploit the same problem that I'm talking about. Is this one root and image tragic? Now you can head to so this is effectively, I just want to download a sample environment, which is a program vulnerable to quite a notorious vulnerability, which I've talked about a little bit about it. And we're going to see how far by using that vulnerability and by being root in a container, an adversary can go. Okay, so to just get this, you can just hit download and it will give you a git clone URL of this. And then I can dump this in the chat, so you guys can, if someone is interested to follow, they can do it. Okay. Back to the terminal. So the purpose of this lab is we're gonna see how bad it gets if we run a vulnerable program or an app. In this case, for our case, is a Flask app. And this program runs by all the default settings. Default Docker file and a default Docker daemon without any hardening. So I've already cloned it here. And so what I'm having here is okay, let's just go through it. It's a Docker file. This is coming from a very trusted source because there is a name secteam behind it and everyone has to trust them. Just run it as root. No, don't do it. It comes from here because I needed to set up some libraries, that was all. But effectively, it sets the work dial as an app. It copies the source, which we will look at it a little bit later. Exposes port 8080, nothing really crazy here. And eventually entry point is this program.py. If I look at the source directory, I've got this program. Oh, let me just make it look nicer. Yeah. And this program, hooray, it's a Flask app. But we also have a dangerous thing here. Not so dangerous, but yeah, popen. So that means that I'm most likely going to run some shell command. So this program simply, well, seems like it has a whitelist of the load file. And by looking at this, it tells me, all right, it's going to accept some files. So user is able to upload some files. Obviously, there are some secret key here. Don't worry about that. Not so much worry about that one. And it seems like once this file is uploaded, this convert file is being called, and this convert file, it just does some thing on the host. It runs convert, and it converts that image that user supplied to us to a target image. I think it just converts everything to the PNG by the looks of it. So I can upload the JPEG file and that become a PNG. That's all. And we're relying on that convert command. Okay, so yeah, so how to run it? Okay, so that was a program. Let's look at the Docker Compose. Let me beautify it. Right, so simple, expose import 8080. And there is one thing here, this is just again for demo, that I just mapped etc shadow from the host to inside the container temp shadow and set it as a read-only. Read-only is a good thing, but the whole point is that if someone is root, they would be able to access that file. So make build to build this container, and then we do a make run, and that gonna gives us 8080 open. Yeah, hopefully everything gonna work. I think I set up some port mapping here, so this should work. 8081 here I have. Perfect. That's it. So that's a Flask app. So one thing I didn't mention is that this app, this program, use that thing called convert, right? And convert is I don't know if I have, is really a popular program utility on Linux that we are using it. Not just in this case, but it relies on a library which is known as image magic. You guys remember this library? Super popular. This library is behind the scene on a lot of Python itself, and a lot of other languages also use this library for any image manipulation. Now, this vulnerability, which had got an interesting name to it, it's called image tragic, which is a tragedy of this image library. Now, there has been quite a number of vulnerability related to the image magic, but one of them that we are gonna see an exploitation of it here is that the way that the image is being parsed it will escape and run a command on the host. And this is effectively this problem here. Some of the image files, including SVG, and in this case, MVG, you can, inside your image file, you can reference an external image or resource. Like, for example, hey, here's a URL for this other image that I want you to go and fetch. Put it this way. And image magic, for making this call to go and retrieve that resource, it actually relies on wget, or it depends on what default shell program you have defined there. It could be curl, it could be wget. And it will actually pass on that URL to that wget command. This is during parsing, that go and fetch this data or information because I want to embed it to this image. A big no-no, because that is a recipe for this vulnerability that we are using, that by just being a little bit smart in a way that you construct this URL or construct the image, you can effectively escape that final double quote here, follow that with the command that you want to run on your on the system that you're trying to target. And that means that by the time this is getting parsed, but once it sees the URL, it will go through the URL, and then here everything will be ended, and then this thing right comes after it will get executed on the host. So that means that, well, we have an entry point to our thing. So just show you an example of this. I just made a really simple image file. And yeah, so I created a fun file called whoami.mvg, and this file is nothing but an MVG file. I actually don't know what is MVG, but you know, it works. So you got a URL here, and then you I close the code right there, and then following with the command that I want. Let's see if this works. So desktop with locus, and then a dead pixel, but let's open the terminal, go back to the Docker, bam, bam, root. So that command got executed, who am I? Okay, so now I'm root. What about the next step? The next step, this will be again exercise for anyone wants to do. I want to dump that shadow file. Simple, convert, come back to the terminal, here you go. You got the code execution right there. Okay, so a quick things how we fix this. Well, do not run process as a root. Classic, but it's not that simple in Docker. Define a user group, and this is a user instruction with a UID and GID at minimum. Please do make sure that this UID and GID exist. Do not just do a user of something random. That has to exist before, otherwise you may map from Docker to some other users on the host, and that get a privileged access. And from Docker 1920, we do have this thing of rootless, that the whole Docker daemon runs as a non-root. Okay, I didn't have time to go through this. Just to recap, we are talking about three scenarios here. User in a container is a root, container engine runs as a root, disaster. That's the default situation we are in. User in a container is root, container engine does not run as a root. Thanks, if you are in Red Hat, that's most likely a default situation with Podman. We have a medium severity here. The happy days for security is this: non-root users, this is a rootless mode, and non-root container, very low best practice severity. Is that all? Does that mean I can't run a root inside a rootless container? Yes, you can. Perhaps in another session I will talk about that. But let's just aim for this for now. Okay, thank you. Sorry, it just took a bit long.
Thank you, Pedram. This was actually, I think, perfect timing. So it was not too long at all, I think. Yes, great talk. Thank you. Very nice. Kind of hands-on presentation, and like practical. So I think we can all, think we've all kind of learned something. So please drop your questions in the chat. I can read them, or Pedram can read them himself.
That was very depressing, actually. Just like the last presentation you had.
Everybody kind of looks sad now.
I'm doing everything wrong every time you come around.
Yes, that's basically our takeaway.
Sorry. I mean, better we know about it, right? I personally sad too, because I felt that often we learned the lesson, and we're going forward, you know, we're gonna do things a bit better. But yeah, some of these things that we are using, it just seems like going the other way. And it just makes it super hard. I don't really think this should be a engineer's job or even DevOps person job to do all these things. I mean, do you do any of this when you run Apache or Nginx? Just push the config and it runs and it actually does behind the scene all the non-root thing. But yeah.
But I think it's nice to have this in mind in the future. And it's not, I mean, there are small steps you can take to improve significantly. It doesn't have to be perfect on the first go, but it's important to be aware that you may have gaping holes.
Yeah, so basically it's good to be scared. In this case, I think. So we really don't have any. Do you guys have any? Okay, Dror has a question.
So I have a question. So at my work, I usually the setup is that I usually use ECS, the container, Elastic Container, something on Amazon, and I am in charge of my own images and then running containers. But I don't do anything on the host. I don't set up the EC2, the actual instances, the AMIs, the images that they run. So I don't have access to actually knowing what users exist on the machine. And you said that I should strive to have a user ID, so I can choose a user ID. What would you recommend that I do if I don't know what users exist on the machine, but I control my own image?
I hope for the best. I would say. I mean, if you know the distro they run, most likely they have a nobody user somewhere, which hoping that will be a user that nobody uses it. The problem is often I've seen people just choose a random UID, like, I don't know, just 1,000 or 1,000 or 9,999. And then that is, for example, mapped to perhaps the SSH user on the host, and it has actually privileges. So it doesn't. Typically, the people who need to deploy, who are in charge of deploying your containers, they should actually agree with the team that, hey, guys, we need to, agree on user 1020 something, and that everyone will follow.
Cool. And I can just demand it. Have this user, a nobody user. Give me this user ID.
Yep.
Okay. Cool.
Yeah, I have just a basic kind of Docker security short question. In the beginning, when we were like kind of identifying security issues in the Docker image or Docker file, you said that when, the non-official image was used, right? So is that like always a bad idea, or how to, is that always a security issue by default, or?
It's just a chain of trust, right? So kind of you're running someone else's code. And I know these days we run a lot of code of others, but that means we not only run it, we've actually, so whatever happened to that image, it's gonna impact us. I didn't talk about actually the official images that also get impacted by this. So a lot better if we try to use an official image, or maybe a safer container registry. I don't know if anyone knows something better than Docker Hub, but anyway, yeah, eventually we will find our way to a Docker Hub.
Yeah, that makes sense. We'll keep that in mind as well. Anything else from anyone for Pedram, maybe?
So another thing I have is that I also build images, and I do need, while building them, to use some kind of private something repository, maybe the Python PyPy private repository, or maybe something else. And then I don't use a fixed key, but I do inject like in a build argument and then use an environment variable. So it's a token and it has expiration. What do you think about this kind of usage?
So when you mean you inject, you mean you inject as an argument to the Docker build, or you do in a Docker file, you put some?
And in the Docker build, I have Docker build with a build arg, and then in the Docker file, I have, you know, arg something,
Yep.
let's say, and then I use env, and then I set it right after as an argument. I set it as an environment variable, so I can use it in
Yes.
the run
Yes.
command.
And this is you run it on your machine and then you push the image up. Is it like that, or this is part of your CI?
I run it, and then this becomes what is later run on the CI.
I mean, the best thing, I mean, regarding to the token is there are 3 attributes we're talking about: short expiry, super random. I think normally we don't really have access to that because we get the token, and one-time use.
One-time use. Yeah.
So normally the token for the CIs, for example, I know for GitLab, they are one-time use. Like once you use it, you can't use it anymore. That would be the one of the best thing to protect it. But there could be other ways. But if you still need to, you know, pass in as an arg or eventually env, one-time use would be a good one.
Thanks. That's it.
Okay, thank you very much,